Hello, so today we are doing this problem called number of islands. So we are given a 2D grid map with ones and zeros, such that ones represent land and zeros represent water. And we want to count the number of islands. And an island is basically a set of ones, so it's a land that is surrounded by water. And it is formed by connecting the adjacent lands. So we can say that two values are connected if they are adjacent horizontally or vertically. So no, so they are diagonally adjacent, we don't count that. So we might assume that all four edges of the grid are all surrounded by water. So basically, that means we cannot go beyond the boundaries of the grid that we have. So the example that we get here is this set here, and so we have this, and then this one is connected to these ones on the bottom, this one's connected to this one vertically, and these ones are connected to these ones vertically. And so you can see that it's only one island basically. So the result is one. For this one though, it's these ones are connected like vertically. This one here, and this one, and the ones near them. But this one, and this one are not. They are diagonally adjacent, but that's not considered adjacent in our case here. And same thing for this one. So we end up with this one, and then this one island, and then this island here. And so we have three. And the problem wants us to just count how many do we have. So the way we can solve this solution is, you can think of it as DFS or fluid fill, where basically we will just start from position in the grid. Let's say this one 0 0, and keep expanding until we reach and keep expanding horizontally and vertically, and either put the ones that we visited in a set, or in a list to keep track of the ones that are visited. Or doing another trick is, if we visit one, just put 0 instead of 1, so that next time if we visit it, we will find that it's 0 and we will not count it basically. And so we can just go through them one by one, and then each time we can no longer reach a 1 vertically or horizontally, we'll just return that that's the island, basically the island ended. So for example, for this case, we'll go here and we'll stop here, and then we'll go down and we'll stop at this 0. Then we'll go down, we'll stop at this 0, and then here we'll go down and stop at this one, because after that is 0. And once we can no longer find a 1 connected to any of these values, we'll stop and we'll return 1, because that's one island. So let's see how we can write the code for that. So what we need is just to return. So we can do have something called just a helper here that goes through I and j, and just marks all the ones, all ones next to neighbors to the value at I and j, and returns 1 once it can't reach any more land, which is 1 basically. And that way we can just count how many we can find of these, and that would be the result. And so if we count how many of these, that means we can just do sum of helper on I and j. For basically I and j are going to be the entire grid, but here we will have something that if the value is not 1, we just return 0, so that here it counts as 0 if it's not a land. And so we'll say we'll go through, and for j is in range of length of grid I. So this way we are going through all the values in the grid, and here we'll check first if it's in the boundaries. So let's check if in boundary, and if it's not, we can return 0. And so here, instead of adding to a list the visited nodes, we can just set them to 0 because they are no longer accessible. They are already counted, so we don't want to count them again, so we can just... So this is a useful trick in general for DFS. You can either have a list that keeps track of the visited ones, or if you can modify like whatever structure you have, like if it's a grid or a graph, you can just modify it. You can just put the value that you don't want to count and replace that value with it. And that way you won't count it next time you visit it. And so what do we want? We want to visit all the neighbors. So visit here, let's call this visit just to make sure it's more clear. So the way we can visit all neighbors is we can just map visit on ij. So we want to map that for all the neighbors. So those would be i+1, i-1. So only the neighbors horizontally and vertically. And those are, so for i+1 it's j, for i-1 it's j, and then we can have the vertical ones would be j-1 and j+1. And so this is a useful thing. So for map, we can map the function, and since the function can receive I and j, you can just put the list of values for the first parameter and the list of values for the second parameter, which is what we are doing here. And we end up with passing to visit i+1j, then i-1j, and then passing ij-1, and passing ij+1 to this function. And that way we would visit all neighbors. So we want to map this, and at the end, if we then visited all neighbors, so since this visit is recursive, so it will pass again here and visit all the neighbors of this one too. So this one will finish only after we visited all the connected ones vertically and horizontally. And that means it's one connected island, and so we return 1. And that would sum up all the unique connected islands. And then here, to check the boundaries, we can just check that I is between 0 and the length of the grid, and that j is between 0 and the length of the grid at I, and also that it's a j value, it's a value 1, it's not 0 because that's not considered an island. So let's say 1. And this should do it. Okay. Let's see, why is this? It's equal this. Yeah, this should kind of be good. Okay, so we have an issue here where it says 9 instead of 1. Yep, so for Python 3, we need to do this. Yep, it's not equal, actually. I'm not sure if this list is necessary here. So let's see. Okay, still 9. Okay, yeah, Python 3 map without list kind of messes things up. So we needed that, and let's submit. Okay, so that passes. We can solve this, make this a little bit shorter with a nice trick in Python. So Python has these complex values that we can use. So where plus 1j like this. So this is a useful trick if we want to not have to go through like all neighbors in this cumbersome way. And so we can use this one, which would just be, so this value here would be I, and this value here would be j. And since we are using complex values, we can distinguish between them because j is multiplied by this complex value. It's the complex, part of the complex value, and I is this part of it. So j basically is the imaginary part of the complex value, and I is the real one. And we can transform our grid first. So let me just delete this. So we can transform our grid first to that format by doing I plus j for I in, basically I is just the rows, enumerate grid, and j is the columns. So enumerate row. And that will give us the values. So basically we can map the index and the val. So for example, 0, 0 would be, let's say at 0, 0 we had value 1. That would transfer to being 0 plus j plus 0, 1j, and that maps to 1. And then the value for and then the value for 1, 2, for example, if it was, let's say, 0, it will map to 1 plus 2, 1j maps to 2. So this is a nice way to make it instead of with 2 coordinates, with just 1 coordinate here, which is, and have just map with a key value. And so our visit now doesn't need 2 values, I and j. Now it just needs a z value, a complex one. And we can do the same map, the sum that we did earlier, where we can map visit to the grid. And here we can visit it. So basically we can use another trick. So pop in Python has this way of passing a default value. And so we can just say, if the value doesn't exist, then just consider it 0. So this would allow us to not have to check for boundaries, because the boundary value would not be in the grid, since we put only the values that are in the grid. And so if we say pop of something that is beyond the boundary of the grid, it will just give us 0. And since we don't care about 0 and we are checking that we have only 1, it works out. And so here we need to do the same map of visit to neighbors that we did earlier, but now it's simpler. So in order to get the neighbors, we just do z plus 1j, and we multiply by k, such that k is just in the range of 4. Why 4? Because we have, for one value x, we have the neighbor here, we have a neighbor here, we have another neighbor on the right, and then we have another one at the bottom. And so we can just visit all of these. And since with this, we don't care about the boundaries, this works out. And yeah, that's about it. And then here we can return 1. And this should work. Oh, we didn't return 0 if it's not 1. Okay, so that works. And the solution passes. Yeah, so this is a general nice trick. When anytime you have a problem on a grid that you need to access the the neighbors, you could just use this trick with complex values to make the code shorter and a little bit simpler. Well, if you know this trick already, but yeah, it's a clever one. Yeah, that's it for now. See you. Bye.